Good afternoon. My name is Dwayne Brown with the Office of Communications, and welcome to NASA headquarters. Today, NASA reveals near-Earth asteroid findings and implications for future research from the agency's Near-Earth Object Wide Field Infrared Survey Explorer, in short, NEOWISE. Today's information and graphics can be obtained on the web at www.nasa.gov/wise. We will have brief presentations from our presenters, then open it up for questions at our NASA centers and the phone bridge. Before we get started, let me introduce you to today's speakers. First up, Lindley Johnson, NEO Program Executive, NASA Headquarters, Washington. Amy Meinzer, NEOWISE Principal Investigator, NASA's Jet Propulsion Laboratory, Pasadena, California. Tim Sparr, Director, Minor Planet Center, Smithsonian Astrophysical Observatory, Cambridge, Massachusetts. And Lucy McFadden, Scientist, NASA's Goddard Space Flight Center in Greenbelt, Maryland. And with that, I'll toss it to Lindley to start us off.
Thanks, Dwayne. Thank you all for tuning in to hear about our progress with the Near-Earth Object Observation Program. We're here today to provide an update of our understanding of the near-Earth asteroid population and announce achievement of some significant goals in finding our nearest neighbors in the solar system. Over the past 12 years, our work to find near-Earth asteroids has largely been done by several ground-based observatory teams. But in 2010, NASA augmented those efforts by enhancement of the ground processing of the data being returned by the Wide Field Infrared Survey Explorer.
So one of the characteristics of NEOWISE is that it really was a fairly small telescope in a low Earth orbit. In fact, the telescope would kind of fit under your arm like this, so it's not particularly large. But by virtue of being in space and operating at infrared wavelengths, it's a very powerful telescope, and it turns out to be very good at finding asteroids and comets. Now, if you go to the first animation here, you can see a little representation of what WISE looks like going around the Earth. It's always pointing outward from the Earth, surveying the whole sky, and as the Earth goes around the Sun, this allows the telescope to very quickly and efficiently carry out a survey of the whole sky. And in fact, it was so fast we were able to survey the whole sky twice in infrared wavelengths in only 1 year. And you can see here a little representation of the difference between visible light and the infrared light that WISE was able to see. So this was a very efficient and effective way of surveying the sky. And the original purpose of the mission was actually to study cool stars in very distant galaxies, and it's doing a great job of that. However, it turns out to also be very good at detecting asteroids. This is because it's using infrared light.
First of all, I find it really exciting that scientists continue to find things in the solar system, bodies in orbit around the sun, and objects that are close to our backyard in the near-Earth space. I want to congratulate the team for your successes, and I know from experience that in order to conduct a survey and to locate and discover new bodies from spacecraft missions requires a lot of planning, a lot of ingenuity, huge amounts of computing power, and then hours and hours, months of discussions with colleagues and poring over the data to validate the results.
Thank you. I realize you're focusing on near-Earth asteroids today, but there's been so much talk about the potential for finding a planet X or some sort of large body through the WISE survey. Can you comment on any status on that sort of search, or maybe even reassure people that planet X isn't coming to get them next year?
Yes, this is Amy Meinzer. I'm happy to answer this one. Planet X is not coming to get us. But we are looking to see if there are any other bodies in the outer part of the solar system with the WISE data. This is a very natural project for WISE. And so we're still working on it right now. We've obviously just returned a huge amount of data from the telescope that's going to take us a long time to sort through. But the initial results are very promising. You may have seen earlier results where we've discovered a new class of very cool type of stars with WISE. But the search is still on, and we don't think that there's anything that's hazardous in the outer solar system. We think that this is just a sort of a, if there is something out there, it would be a large body in a roughly circular orbit.
Our next caller, Denise Chow from space.com. Denise.
So when you say the initial results are very promising, yeah, the initial results are very promising. Anything else you wanted to say on that point?
We've actually been able to confirm the discovery of 100 new objects that are these very cool stars called brown dwarfs. And so that's very similar to what people are interested in looking for. So we've actually found some of these that are relatively close to the Earth, but none of these are closer at this point than the nearest star to our solar system. So it's a good start, though.
Thank you.